We live in a galaxy that's more than 100,000 light years across and contains hundreds of billions of stars and all of the planets that go around them. At the heart of our galaxy is a supermassive black hole, surrounded by events of unimaginable energy and violence. That's where we're going today, on our journey to the center of the galaxy.
On a clear dark night, you could see a band of light arching across the sky from horizon to horizon. The Greeks and Romans were struck by its milky appearance, and so it came to be known as the Milky Way. The Greek word for milk is gala, from which we get the name galaxy. A telescope reveals that the Milky Way is actually made of numerous stars. It's the disk of our galaxy seen edge on from our vantage point inside the disk, about 26,000 light years from the centre. A light year, remember, is the distance travelled by light in 1 year, about 6 trillion miles, or 9.5 trillion kilometres. Our galaxy is a spiral, looking like a pinwheel if we could see it from above, and two fried eggs back to back if we could see it edge on. In fact, we now know it's a type of spiral galaxy called a barred spiral. Its spiral arms extending from a bar of stars that stretches either side of the centre. There are a lot of things we don't know about the galaxy in which we live. We know that its luminous part, the part we can see, is embedded in a much bigger spherical region of matter that's invisible. This is the dark matter halo, made of something different than ordinary matter. Dark matter is a major component of the universe as a whole, and all large galaxies appear to have halos made of this stuff that we haven't identified. It's one of the outstanding challenges of physics and astronomy to identify its true nature. The other big mystery concerns what's going on at the very centre of the Milky Way. Again, like many other galaxies, the Milky Way contains a supermassive black hole. It's about 4 million times as massive as the Sun. How do we know it exists and what its mass is? Its presence is revealed by the extreme motions of stars and other material close to the centre. The gravitational pull of the central black hole is whipping stars around in high-speed orbits, eventually causing some stars to break apart before swallowing their contents. Specifically, the movement of a star known as S2 has been accurately tracked by astronomers as it orbits very close to the object at the exact galactic centre. S2 goes around the central object once every 15.2 years and comes as close to it as 17 light hours, or about 120 times the average distance of Earth from the Sun. This limits the radius of the central object to no more than 17 light hours, otherwise S2 would collide with it. There's also evidence that another star, called S14, orbits even closer at a radius of only 6.25 light hours, about the size of the orbit of Uranus around the Sun. The motion of S2 indicates that whatever it's orbiting has a mass of at least 4 million times that of the Sun. No known object other than a black hole can have a mass 4 million times that of the Sun, crammed into a space that's smaller than Uranus's orbit. So it follows that there's a 4 million mass supermassive black hole about 26,000 light years away from us at the centre of the galaxy. In 2019, astronomers took the first image of a supermassive black hole at the heart of a galaxy. The galaxy in question isn't our own, but a giant elliptical galaxy, M87, that lies about 50 million light years away. The image was obtained by a project called the Event Horizon Telescope, involving some 200 astronomers and an array of observatories in various places from Hawaii to the South Pole. It took 2 years for all these observatories, effectively acting as a single telescope as big as the Earth, to collect all the data needed to create the picture of M87's central black hole and the bright ring of material immediately around it. M87 is a much bigger galaxy than our own, and its central black hole is far more massive, weighing in at 6.5 billion solar masses, more than 1,000 times as massive as the Milky Way's dark heart. But at its great distance, the size of this monstrous black hole and its surroundings is only about the same as an orange on the Moon, seen from Earth. Although the centre of our galaxy is much closer than M87, imaging it is complicated by all the gas and dust that's in the way. Nevertheless, astronomers hope that the Event Horizon Telescope will be able to image our neighbourhood supermassive black hole in the near future. The picture that emerges may not be much more detailed than the one we've already seen from M87. Our very own supermassive black hole may be 2,000 times nearer, but it's also about 2,000 times smaller, so its angular size in the sky is about the same. However, it'll be a landmark moment in astronomy and a giant step forward in understanding the extraordinary events that are taking place at the centre of the Milky Way.